present my screen. Ma'am, can you switch off your screen? I'll present. Yeah, thank
Yeah,
you.
I just
Yes. Ma'am, is my screen visible?
Yes, sir.
Yes, sir.
Can anyone confirm?
Yeah, this is
Yeah, thank you. Thank you so much. Just give me a minute. Yeah. So. Is my screen clear, ma'am? Is it full screen or you're not able to see it?
Yes,
Yeah,
sir.
we can see, sir.
Yeah,
Yes,
thank
sir.
you. Yes, sir. Yeah. So again, welcome everyone for this session. Myself, Arihenth. So I've been working along with NVIDIA on setting up GPU clusters for AI workloads for enterprises and HER research customers. Thanks for SKCT for inviting me to conduct this session on how Python been utilized in specifically for deep learning and computer vision workloads. So this session will primarily cover the very high level overview of Python and how it is used in industry. As faculties, you know what exactly the technology is going around, but the industry faces something actually different, right? So they keep on exploring new things day in and day out. So how this Python ecosystem have been utilized in industries, definitely share this knowledge to your students so that they've been equipped with all those relevance or prerequisite for what industry has been looking out, right? So I've been frequently in communication with different startups and highly equipped people on deep learning and machine learning as a part of infrastructure team to see what they are doing and day in out, day out. So with those experience, I came to understand that how this team, very highly equipped and very highly skilled teams who building machine learning and deep learning model for production day in and out, day out. I've been using these tools and a stack of softwares or libraries to build their end-to-end product workflow. So I want to take this opportunity to give you this information and slowly set the context for what exactly it is and move on to hands-on of how the ecosystem is built and what are the main functions and modules and libraries have been utilized for most commonly utilized in product development environment, right? So with this, like you can transfer this knowledge to your students and help them to equip, and you can also utilize the same setup and leverage this into your own research projects also, so that you are well organized in the research and how research customers also working on this set of stacks and how they've been organizing their own each project life cycle and all those stuff. So with this, today we'll cover what exactly the Python ecosystem is for deep learning and why it's become more popular and how it's being utilized frequently by a lot of product companies out there. And slowly we'll get into what are different environments because when we consider deep learning and computer vision into the picture, it's not like something like web development or some simple automation which will do simple with your laptops, right? It also involves other infrastructure, like you have to consider GPU, and you have to consider your deployment or end-to-end development life cycle of a deep learning model with the infrastructure you've been using, right? So typically you've been starting with Colab, but now slowly things are moving out. Colab is something, yeah, you can explore a lot of things with Colab and trying a lot of things with Colab, but still if you want to build something heavy to research or heavy to production, of course you need to have your own setup and own infrastructure. I could see a lot of colleges have been setting up their own GPU infrastructure. Even I've been working with different customers who we already set up the supercomputing infrastructure for them, and they've been working frequently with that and seeing how they could leverage the end-to-end GPU workflow instead of using some tools like Colab or Gaggle GPUs. So this is the idea for me, so that I can transfer this knowledge to you, and in turn, like, you can transfer this to your students and get this in the context. So next, we'll see why just normal Jupyter notebooks is not enough. Yeah, of course, it is very much enough for learning, but not enough when you get into production. So in a way that if you think, why don't we start with just how companies are working out, and not just with Jupyter notebooks. Like, yeah, of course, Jupyter notebook is very important. Like, you can learn a lot of things with that, but typically organizations, they don't use it because they build Python in modules or in functions. They follow OOPS concept end to end, and they follow organized way of managing the project end to end, and the entire life cycle of the product, deep learning development, follows the same software SDLC format. So while we learning or teaching the students itself, like, when we try to slowly incorporate these things into the learning process, I think that is what exactly the industry also looking for from the students. So they've been looking for some prerequisite which they don't want to transfer the knowledge they're expecting from the students, and in turn that they will go with more advanced concept, whether they are in internship period or they have been newly joined in a company. So I want to set the context here for that also, and then we'll slowly move on to a hands-on session with computer vision, and we'll just see what are the predefined functions with TensorFlow, and we'll set the context of how the TensorFlow and PyTorch is differing, and what are the commonly used functional libraries in that. And then with that, we'll wind off this today's session, and tomorrow we'll see how we can incorporate the software methodologies into the end-to-end life cycle, how we can monitor our scripts, training scripts and data sets, and how we version control them, and slowly how we organize or structure the deep learning computer vision project, how we manage labels, how we manage image data sets, how we label it, how it's being organized, and we'll move on to what is data pipeline with TensorFlow, and how you use the data pipeline to load your own data sets and pre-process it, and I will train a simple model with the TensorFlow. And then we'll also see what are the different Python external modules available in the market, in the ecosystem, and see how we leverage in every development process, like end to end, like from pre-processing of data till training, and then slowly validating your model, and then deploying. Because now we are moving into the pace where deep learning is not just experimenting or building a research. More of productization is happening around deep learning. It's becoming more relevant because companies have understood they have data and they need a skill set to build their own machine learning or deep learning model, because not a single person or not a company can build a single product for all the different companies available, because each one have their own problem statements, and they know what data they have, and they know what problem statement they have. So it highly depends on each entities to identify how they can incorporate data science into their workflow, or which kind of solutions they can get in. For example, if it is a manufacturing, of course computer vision plays a major role, because there are a lot of tasks in manufacturing which can be automated using computer vision. So likewise, in finance, there are different perspective of problem statements. Likewise, different sectors have different problem statements. So each one's domain knowledge is quite important here, because as we see, the data is playing a major role here. Most of the models that we have, pre-trained models and structured models available in the market, but once you understand the data and identify the data and how it works, that is the golden opportunity we have here. We have there. To mention, like, medical imaging is something very booming, and you can see that in next 5 years you could see a lot of research and products coming out of medical imaging. I can see the traction making around, because a lot of medical colleges also investing on the infrastructure. The only thing is they don't have a right skill set technology skill set, they have a domain skill set. So these kind of mappings needs to be done, and I could see a lot of potential opportunity for you faculties to do a lot of research in this area which were experts in. So first, to start with, I want to set up a simple bird's eye view of what the common structure of Python is. You all been already working on Python. A lot of you have been experienced in building things on Python. So just to set the context of how things are moving around, like typically you see we in Python we deal with only two things. One is a Python file. One is standard inbuilt libraries, and we have a lot of external libraries. One of the reasons Python became more popular is that you have lots of external libraries built for it. You don't want to write anything from scratch. Like if you're very much comfortable basic fundamentals of Python, like data types, what are structures and data structures, and what are the flows available in the Python, you're pretty much comfortable using your external library or standard inbuilt library and slowly learning towards it, right? So this common structure is what typically we follow in, if it could be any development project, whether it's web development or whether it's common automation or networking or even data science, right? So we normally follow this structure, right? We have multiple Python scripts, and in each scripts you have different modules, and we'll map each module. If required, we'll use inbuilt modules. If required, we'll use external libraries into it. So this is what the structure typically would be, right? The common basic structure. So the Python program itself have been you could see into it as three ways. One is the modules, one is package, and other one is libraries, right? So typically when you have a file with a function, you could see as a module, right? You can call that function in any other scripts using the import function, right? You can import that file and you can call the function in that particular Python file, right? Similarly with package, when you have multiple Python scripts with multiple functions into a single folder, like you could see as a package, right? Like whenever you're creating a proper production system, right? Your entire project will be packaged and built into a single package, right? So you package it, and you will have different deployment methodologies to deploy it, right? Either you could just deploy into a Python environment, create your basic Python environment, any server, and deploy it, or you can build into a Docker image and you can deploy it. So of course packaging is something very important, and libraries, of course, whatever we use now, like either TensorFlow or the NumPy or Pandas, everything is being pre-built with pre-built functions. You can just pass whatever parameters required and it will do the task for you, and it has a combination of functions which is required to solve a specific problem. Like if it is TensorFlow, you can create solve machine learning problems, deep learning problems, create a dataset pipelines. Like this libraries will slowly evolve, and each and every time it evolves, it comes with the new functionalities and features. So why understanding this basic is very important, right? So once you understand how these things have been built around, it's easy for us to understand other new libraries coming up, because this is structure. Most of the libraries also follow the same structure. So once we understand that or connect the structures, so it's easy for us to learn the new libraries and utilizing those new libraries, and we could also easily debug where the issue is, in which function it's happening, or which script it is happening, in which package and which script it is happening, or you can fix that. Those kind of things we can easily learn when you have the connect of how a particular package, how a particular library is built upon, right? Once you know what are the bits and pieces of files which have been combined to build that library, it's easy for you to understand the structure and start coding your own thing. So when you, as I told, like we have built with only two things. We use two things. One is a standard library modules, which is inbuilt with a Python. When you just install a Python itself, it will come along with the Python. And you have something called external library module, where you install it from Pvt py repository, right? You will do pip install. You can find thousands of external libraries in that repository, which is also maintained by Python ecosystem itself. You can just pip install that libraries like matplotlib, numpy, OpenCV. These kind of libraries you can just pip install and you can start using it. So when you say standard library, you able to see my slide switching? Is there an issue? Can anyone confirm?
We can see, sir.
Yeah, thank you. So when you see standard libraries, so you don't want to do anything. Once you install the Python itself, it comes along with the Python. And of course, you can create your own modules or library if you're writing a specific function or specific problem, solving a specific problem statement. Typically, you will have libraries in inbuilt Python libraries will have modules. Like you can just import a single function of the module, or you can import a exact every module, every function in the particular module, right? Like when you've been working on Python, you may know, like you always use this from math import specific function or specific module, and from math import all the functions. This is something you can also do it, right? You can create your own files, add multiple functions, and import that file into your new scripts, and you can just use that particular function in that module script, right? This is how deep learning engineers also building their own end-to-end project scripts, because they'll have a separate script for training. They'll have a class in the training file, and they'll have a separate script for config file where they can pass the parameters, all those hyperparameters, and they'll have a separate script for validation file. So this is how they package it. So understanding this also help us to understand how engineers are building their own deep learning functions or modules, and they are putting into the production. And now we are coming into something important called external libraries. Of course, we have a lot of Python inbuilt libraries, but when we come to machine learning or deep learning, we commonly use external library, right? In top of Python. And of course, in deep learning and machine learning, we're not just running a software which runs on a CPU, right? We also dependent on GPU. So a lot of wrapping has been happening around there when you run a model in Python using some external library called like TensorFlow or PyTorch. For that matter, even OpenCV supports GPU acceleration. So when you consider this external libraries, typically all your models have been built around this, right? So you use NumPy for image conversion, you use OpenCV to do the pre-processing, you use TensorFlow PyTorch data loader to load your data and organize your data, and then you based on your option of framework, you choose how you are going to flow the end-to-end flow, like how you set the parameters for training, whether you're going to use a class for training, or how you're going to set the end-to-end script flow in your model building, right? Typically in Python, you have as you know, like you have a lot of external libraries available. You have web development, you have complete stack of web development available in Python, and you have complete stack of automation and scripting networking functions available in Python, because most of the DevOps workload also have been automated using Python nowadays. All your OS controls, instead of self scripting, people are using Python to automate the end-to-end flow. So typically, once you know Python, it's easy for us to set into a startup ecosystem or a product company ecosystem, so that you know what is the end-to-end flow is with machine learning and deep learning in specific. So when you consider external libraries for machine learning and deep learning, there are a lot of things available, but you commonly use Matplotlib, Pandas, OpenCV, TensorFlow with Keras or PyTorch. So when you consider computer vision, specifically computer vision with deep learning, you commonly use these three things. One is Matplotlib, NumPy, you use OpenCV or Pill, and you use TensorFlow with Keras or PyTorch. So this five libraries have been commonly used by industries also. Of course, if it is a machine learning project, if it's a time series project, so that there is a difference in that. But with computer vision, so these are the common libraries you've been using in computer vision context. So if you understand these libraries and common functions have been utilized into the computer vision models, so it's easy for us to connect the dots. When you even read someone's scripts in the GitHub or someone's scripts in Kaggle, so it's easy for us to understand and connect the dots and get the quality workings out of the scripts and incorporate into your own coding style. That is also help us to fast pace our coding style and help us to write a clean code. Okay. So another thing we have to consider before starting a work, right? So our Python development environment, why it is so important, right? So of course, when we are just doing a lab sessions, so we don't care about we don't care much about how I've been starting, how we're installing the environment, and why it is very important. At least when we're in the college, students don't get why the environment is very important. But once you get into the development, actual research or actual development, so your environment is very important. That speeds up your process, that help you to manage your end-to-end workflow efficiently, right? So you have typically have been used these two environments. One is you definitely have been used Conda, because Conda supports both Linux and Windows environment, and you also use virtual environment which pre-built with Python. You can also use it in Windows and Linux environment. But you have something called containers, right? Why this is very important, right? Because most of the deep learning models nowadays, they don't deploy it in a bare metal server. They don't have a single server or a computer which they install some OS. On top of that, they install all the packages required and they deploy their codes in there. They don't do like this. Nowadays, all this have been following something called microservices, and they're using cloud native tools to build the application and deploy it in an efficient way. So this is very key here, because while you coding itself or while you teaching the coding itself, when you set the context of how the flow would be, not just the coding, they can easily learn a lot of coding stuffs over the internet. But still, when you're able to connect the dots of how the script have been built and how it is packaged, how it is validated or tested, and how it is deployed, this bits and pieces, when you're teaching, when you connect these bits and pieces, so it's easy for someone to understand how the flow would be, and they know what are the fundamental tools they need to learn, so that it's easy for them to get into the workspace and start the development process. Not they want to learn every tools from the scratch, and they have to understand how the flow is. When you set this context while you teaching this lab session itself, so it's easy for them to understand and get the flow of how they're gonna start writing the script and how they're going to deploy it. This end-to-end process, if they are clear, so this would help highly to get into the workplace and start building their own product. And it is of course very much helpful for the research. So when you organize the content properly, and when you have the proper research formats and proper version control out there, so it's easy for you to manage their end-to-end computer vision project flow. So of course, we have used Conda, we have used virtual environment, but why we need something, we need source code editor, right? So of course, you may suggest students to learn it from scratch, debug your own code, understand what's the error it is throwing, what is type error, what is import error, what is module error, these kind of things you have been teaching your students. But of course, a source control editor is also a tool which someone should be very good at, right? So it could be any source code editor, but once you know the fundamentals of what the tool offers you and how you use it for your benefit, that would help you to write clean code and help you to fast pace your code writing skills, right? So once you understand the source code editor, you know how to leverage that tool to your potential, so that you can write your codes in a faster way and you don't make a lot of mistakes in your code, and you slowly learn how to overcome those small errors you're making in the code, right? So in working context, understanding this tools is very important. My kind request could be, while you're teaching your students also, kindly emphasize on the, because once you know this, so it's easy for you to connect other dots and start writing your codes in a very faster way. Of course, Jupyter Notebook also is very important, because to start with, when you're learning, it helps you to fast pace your learning, and slowly you can move into source code editors and build your scripts as a files, not as a single Jupyter Notebook scripts, which ideally is not right in the workplace environment. But of course, with research environment, that would be highly helpful. Coming to the point, containers, why it is very much important. Like, let's say you have a Windows laptop and you set up a Python environment with a TensorFlow installed, NumPy, Python, NumPy, OpenCV installed. So you're running your codes, and let's say your laptop got trashed. So what you need to do, you have to again set up the same stack in another laptop, and you have to start running it, right? This is not ideal setup for someone who's working on a research project, or someone who's working on a company who build a product, right? And this is not ideal for even a production. This is not very much ideal for even a production environment, right? So to mitigate that, to come over that, you have something called containers. So you know Docker, right? So Docker, it's a software where you can virtualize the software layer of it. You use the same hardware of your server or a computer, but you only virtualize the OS of, above the OS, you just virtualize the software layers. You don't virtualize the hardware layer, right? So this help you to package what are the required things, as was saying example for Conda. You can just package all the relevant softwares like Python, NumPy, OpenCV, TensorFlow into a single Docker image, and you can just port it to any computer with OS, Linux OS, right? So I would suggest also emphasize more on containers, using containers, so that even for your research projects, that's how a lot of research projects, they also started using cloud native tools to do and present their research. You could say why this could be that much important, but this is something very fundamental, so that it's easy for you. This is hands-on knowledge, right? So you can just have this in your back, and you can use whenever you need, and you can slowly scale your skills on core concepts, instead of learning these things whenever required, right? When you set the fundamentals of this, it's easy for them to follow, even if you are in research, or even if you're working on some product environment, right? So typically, when you say containers, you have something called image. It's a static file with all the relevant software packaged into it. So when you have a Docker installed in your system, you can just pull the image. It could be a TensorFlow image, Docker, a Python image, or it could be some PyTorch image, and you can just pull and run that image. When you run that image, you will have a runtime environment called container. Let's say you have a TensorFlow image. When you run that image, you have something called TensorFlow container. So once you run that image, you can run a Jupyter Notebook inside that container, and you can start writing a scripts, or you can just write some scripts in any source code editor, and you can package that scripts into a container, and you can deploy it. So I'll just show the sample of how you can do that, and we'll move into some basic TensorFlow classification pre-processing operations today. So I'll share a few links for you to set up this environment. So typically, if you are a Windows user, you'll be using a Conda environment. If you want to use GPU in that, typically, if you want to use GPU, I would highly recommend Linux environment. Windows is not an ideal setup for you. Of course, you've been using Colab, but I would suggest Colab is very good for learning, but if you want to get into proper deep learning research and help your students to get into proper infrastructure way, and of course leveraging a GPU servers in your college is highly recommended, and you can explore and play with those servers, and see how you can build the end-to-end stack in that server, and started leveraging it, right? So if you have a Windows user with GPU in your laptop, let's say you have a 1000 series GPU or 2000 series GPU, of course you can have your own Conda setup, and you can install all predefined requirement for the utilizing the GPU by TensorFlow or PyTorch, right? So if you want your TensorFlow or PyTorch to use your GPU, you have a set of stack, right? You need to install a driver, you need to install a CUDA toolkit, you need to install a CUDNN library, and this stack will help you to leverage help your PyTorch library to leverage the GPU hardware underlying your laptop. Or if you have a server with Linux, you can have a different setup. I'll also explain what kind of setups you have when you have a GPU servers or GPU workstation. Let's say if you don't have a GPU workstation or server, you are using a Windows laptop, you can always use this setup. And if you're also using a Windows laptop without GPU, it's pretty much work with Conda and Visual Studio Code. And one more thing, why it is very important to use your source code editor, right? Because now companies looking at students to understand all the gits and version controls predefined, right? They want them to come up with all those knowledge. They're not they don't want them to teach all those stuff, right? So even in research projects, if you check any research papers code repos, you could see how good they are at version control. They publish the results, and they manage the version of all the scripts they've been used on all the results they've been publishing, all the data sets they have. These kind of things will add value to your exact research projects, and it's easy to follow the research projects if someone joining a new into your team, or you have multiple team members handling a single project. So these kind of things, having your git repo up and version controlling your entire structure is highly recommended, and I will request you also to ask your students to follow this kind of structures. And let's say you have a server with GPU, or you have a workstation with GPU, and you need to have a container based setup. So using a container for building your models is highly recommended, because if you see any reference in YouTube, or if you see any reference when I was discussing with multiple peoples around the industry, that mostly they'll use container based environment. They build a model and they will package into a container and they deploy it. So of course, for your research projects also, if you have some grants approved, or if you have some fund, if you want to set up your own research setup or a GPU server, using a container based environment would be ideal for you. When you have multiple students, or let's say 3 to 4 students using a single server, or let's say 50 students using a single server, so this setup is ideal for you. So when you understand this workflow, what is the stack of it and how to use this, so it's pretty much simple for you to leveraging the underlying GPU on your hardware, and managing multiple sessions of it. Let's say you don't want to install TensorFlow from scratch. That's taken care. You just want to code your model. You just don't want to install a TensorFlow. You can just pull a container image, or a Docker image, TensorFlow Docker image, or PyTorch Docker image, and you can just spin off that and start coding your TensorFlow or PyTorch code. It stands same for any other libraries you've been using for deep learning or machine learning. So, and again, when we discussing or emphasizing Python with computer vision, your GPU comes and plays a major part, right? So most of you have been explored CUDA. Can anyone like if anyone tried this kind of setup in server or server based GPUs, you can just say yes in your comments, because I want to understand like how many of you have been tried using GPU servers and leveraging their workloads. You can just mention yes in your chat window. So none of you have been tried. Yeah, Google Colab. Okay. So anyone have your own GPU servers and tried how to set up the environment and start running your model scripts? You can just say yes in your chat window. Okay. So I could see very few have been tried, but of course you're also applying for a lot of your research projects, and you also want to set up your own GPU servers. In that case, you can just let me know, like I can help you with that. I'm just can find my mail ID in the chat window. So yeah, of course, Google Colab, a lot of have been tried on that. But when you applying for a research grant or when you're working on a research project, so definitely you plan to have your own setup, right? So I'll also give a glimpse of how to have your own setup and start exploring the setup and building your own models with it. Okay. Yes. So now coming to the point why GPU is important, right? So when you see before 2010, you won't see that much traction happening around artificial intelligence, specifically with deep learning. Like, but after Google came up with using a GPU for their one of the research papers, then the whole point of using GPU for acceleration are being turned around, right? So now all these frameworks you have, most of the common frameworks you have, it supports GPU acceleration, right? So with GPUs in place, like you can have your own data sets and try out the new models for your problem statements, because until and unless you're using a MNIST or common models available in the internet, you don't see much of difference, right? It'll run easily on your CPU, and you don't want to worry about your underlying hardware, right? You can just learn using these models. But actually, when you're using your building your research projects, and when you have your data sets, when you're publishing your results, so this is something very important, right? You need to publish your results. You need to worry. You need to consider your accuracy. You need to consider your training time and what kind of models you used. How you tweak that models. Those kind of pictures come into place, right? So this having is this GPU is very important to accelerate your training process. And of course, now deep learning is becoming end-to-end GPU accelerated, starting from pre-processing your data till your deployment or inference of your model, right? So this GPU infrastructure is becoming quite relevant, and I could say a lot of colleges are setting up their own GPU infrastructure. As this pandemic a bit slowed up those things, but still new things coming up, new research funds coming up. Professors have been very much keen on setting up this setup for the research scholars or for the students to leverage this and start using it. I'll also show you a sample of how you can use this and set up this, and we can slowly move into our actual Python part. Okay. So when you see a deep learning stack, right? So as I told you, have three things, right? Either you be using Colab, and you have a Conda stack, and you have a NVIDIA or a container-based stack, right? I'll tell you why you need to have this NVIDIA stack if you're working on a research project or if you're working on a product development, right? So typically Colab is something for you to learn. You can start just spin off the Colab instance and you can start learning it. You can get K40 GPUs, or sometimes you can get T4 GPUs, right? And Conda stack, let's say you have Windows environment or Linux environment. You just want to learn and set up it. I mean, simply, you just want to install the Conda package, and you can just want to spin off your Spider or Jupyter notebooks. You can just go with the Conda stack. And again, in Conda stack, you have to install everything and you have to maintain it end to end, right? Coming to NVIDIA stack, it is not something similar to these two things. NVIDIA stack completely uses Docker, and it provides you a set of containers. It provides you a TensorFlow container, PyTorch container. It provides you a set of collection of pre-trained models for image classification, object detection, image segmentation, and pre-trained models for all common NLP tasks. So there is something called NVIDIA NGC. It's a public repository to use all these models. The only requirement you need to have is a basic. If you have a laptop, you need to have a GPU with 2020 series GPU or 3000 series GPUs. Or if you have a GPU workstation or server at your college, like you can leverage those things and start using it. So typically this NVIDIA stack would be very ideal. Most of the universities have been using this NVIDIA stack, and and building their research projects around that. So even if you have a laptop, so this could be the common dependencies. You need to have NVIDIA driver, CUDA toolkit, and CUD installed. On top of that, you have a lot of other dependencies. Either it could be a TensorFlow GPU or Python GPU. You have to install it. But manually installing it every time is tedious, and using your new version of tools coming up or packages coming up. Let's say you have using someone else's code, or you're using research projects or papers code into your own environment. You have to exactly match those environment, right? So having this installing manually, it's quite tedious process. Instead of, you can use containers or NVIDIA stack to leverage those things. Yeah. So as I was telling, commonly used stack, when you write a TensorFlow code or Python code, you will be using these three things commonly, right? You use NumPy for handling the matrix, and use Matplotlib to plotting all your images or all your graphs, and you use PAL or OpenCV to pre-process your image data, right? And handle your image data. And coming to data handling, and how you structure your folder, and how you set the pipeline for data, and how you label your data and manage the labels of your data. All these things have been taken care by your TensorFlow data pipeline or your PyTorch data loader, right? Yeah. So moving on to our hands-on part. Just give me a minute. So until now, any questions you can ask on the chat window. If there is a question, I can answer that now. So this is to set the context. Like if you have any questions, you can post it in the chat window. Is there any question? Okay. From research point of view, Matlab or Python, which one is easy to work with? So yes, ma'am, that's a good question. So it completely depends on your research work, right? So if you're working on computer vision, I would suggest Python with TensorFlow or PyTorch would be the ideal setup for you instead of Matlab, because you could have a lot of medical image processing. As of course, medical image processing also, you have something called it could be advanced tool, but you have something called Clara SDK from NVIDIA. So with this SDK, you have a lot of predefined structure for your medical image processing, and you can play with your DICOM images, or you can play with your JPEG of your scanning images. So I would suggest just go through this Clara SDK setup. And of course, with medical image processing also, Python with TensorFlow or PyTorch would be the ideal option, because you have a lot of support tools available for you to do end-to-end workflows and publish your research work. Yes, ma'am. Any other questions? So today is a mix of a little bit of theory and the hands-on. Tomorrow we'll have a end-to-end hands-on session, and playing with our, the 15th we'll have an end-to-end hands-on session, playing with our own data sets, and how we leverage the infrastructure we have. Okay, if there is no question, I can slowly move to the part. So yeah. Okay. So before going on to that hands-on part, I just want to show a few things. Yeah. So I was discussing using a Docker environment for a development is very much required nowadays, because you could see whether it's a research project or whether it's a company or building a product, all these guys have been started leveraging this container-based setup. So to have this setup, I'll share you documentation in the main. You can just use that step-by-step procedure to have this setup. To just to explain what it does, we have something called NVIDIA Docker, which is a package to set this container-based setup in your own laptop or a server, and you can download whatever images you want from a website called NVIDIA NGC. And it's a repository of collection of all your models and tools, and you can leverage this, and you can pull whatever images you need, and you can start working on this. I'll just show this because it is a very important tool. It will help you to fast pace your deep learning workloads or learning computer visions, all those stuff. So when you go to container, you can see all these containers have been pre-built and packaged for you. Only thing you need to have is you need to have a Docker container setup. That's it. Once you have the setup, you have to just pull this command, and you can just start running your models. And you have an example scripts available in the container image itself, and you can also understand what the best practices they have followed, and you can leverage in your own workloads. And to add to that, you have a lot of other tools also available for you, like transfer learning toolkit, Clara for medical imaging, and natural language processing, Java for natural language processing. Similar to that, you have a lot of tools for speech recognition, and very much high level tools for computer vision workloads, whether either it could be image classification, object detection, or even object segmentation. Yeah. So yeah. So just to give the glimpse of it, like I'm having a TensorFlow image here. So if I want to run a TensorFlow image, I'll just use a run command to run it. And once you run it, I'll go to the particular, it will get into your runtime environment, and you just want to run your Jupyter Lab or Jupyter Notebook there, and it will spin off the Jupyter Notebook with GPU visible to it, right? So this setup, you can, I'll share you the documentation. You can look into it and see how we could set up, and we can also have some other session if we have an opportunity, and we can discuss this in detail. So for my setup, it's running on a container, and I've been using NVIDIA Docker, and I'm using this setup to run my scripts. So just to understand how many have been, what is a common tool you've been using to do your computer vision scripts or build your computer vision models? If you could just mention that, that would be helpful to take this session forward, and I can suggest you how you can migrate to this setup. Your common tools you've been using, Collab and other own tools you've been using in your laptops to teach your students, or things you've been using. Okay, Collab and Jupyter. Okay. Yeah. Okay. I could see a lot of Jupyter notebooks. Of course, you've been using Python. Okay, Python. Okay. And how many of you worked on TensorFlow or PyTorch? Just creating a simple model. You can just say yes on the chat window. Okay. PyTorch, TensorFlow, any deep learning framework for that matter. So just to understand for that, I can get some context here, and I can in next session I can see what the ideal things I can discuss and show you the demo with, and I can also make sure that whether you could use that in your own laptop, and how I can make you to use that in your own laptop and try those things. Okay. So I could see a lot of TensorFlows, PyTorch. Okay, fine. So others, I assume that you're not working and you just want to start up with leveraging these tools for your deep learning framework. Okay, fine. Okay. So coming to our hands-on part, so when you have the computer vision problem statement, so typically you have three things, right? So you have object image classification, you have object detection or localization, and you have a image segmentation, right? So whatever your problem statement or your problem could be, the workflow is similar, right? You have to, one is you have to get your data ready. You have to examine and understand your data, or you have to collect your data if you don't have a data, or if you're using your data from some of this repo, or you're using your created data. You have to understand it, how the project is structured, and all those things, right? And then you have to build the input pipeline. There are two ways of doing it. Either you could use Google datasets, or you can use TensorFlow datasets to build your own custom pipeline if you have a manually recorded the data and organized in your own folder structure, right? This data input pipeline, you have multiple ways, which we'll discuss tomorrow, how manually you can set up your own structure and create a folders of data sets, and build the pipeline and get the data into your code and convert them into a matrix, and then feed it into the model training function, right? This we'll see tomorrow. As of now, this is the next second step of your end-to-end flow. Build an input pipeline for your data sets, right? Once your data sets is ready, and you have something called pre-processing, right? Either you have to convert it into a ampere array, and you have to do a lot of pre-processing, like it could be a augmentation, or it could be changing the dimension of the image, normalizing your image, and setting the resolutions of the image at the common front, and all those stuffs, right? This pre-processing also needs to be done. And then you slowly build the model. You have a function, and you have to define how many convolution layers you need to find, and how many flattening layer, and then finally how many, based on the number of labels you define, what are the final output layer you need to have, right? So once this model building has been done, you have a common function involved in your TensorFlow or PyTorch. You have a convolution functions pre-built in that function, TensorFlow or PyTorch, and you start building these functions, right? What are the common functions, and what is the majorly common used functionalities in TensorFlow, we will discuss, and we will connect the dots of how each function works in the code, and from pre-processing your data till your deployment, how these functions are being, till your inference, how these functions are being interconnected. We'll discuss it one by one, and you can I can give you cheat sheets of how this function have been working, and you can start building your own small models and connect how these functions have been work in correlation with each other, so that your entire model is trained. And I'll also share some cheat sheets for debugging and finding errors in your code if you're using TensorFlow and Keras. Yeah, so you could see here, typically when you have a TensorFlow, when you're writing a computer vision image classification models, or even for the matter object detection models, you have a matplotlib to plot and see how things are going up. Whether it's image, you can plot and see, or you can also use OpenCV to pre-process and plot your data, right? Matplotlib, you can also use it to leverage. You see a difference between mapping your validation and your accuracy data sets, how it's working on. You can measure your loss function, and you can measure your accuracy using this, right? And of course, NumPy, majorly all these tools use, frameworks, libraries will use NumPy, because your core thing is convert your data into a numbers, right? So you have to pre-process it into a numbers. Either it could be a 3-dimensional matrix if it is RGB image, 2-dimensional matrix if it is a grayscale image, or it could be a 4D image also if it is a 3D image. Like if it is a medical imaging, you have a 3D structure of the image. So these things, of course, NumPy is a major player here. I would suggest you can emphasize a little bit on NumPy, pandas. You can also learn fundamentals of these two libraries, because these two libraries have been highly used in any setup, deep learning setup, right? So we could also cover a separate session for that, but keeping time on mind, like I want to give you the entire structure and overview so that it's easy for you to connect the dots and set the learning process and help your students to have the flow of learning, so that they touch base with all these tools and they know how the end-to-end structure of the deep learning projects flow, right? And of course OS and Pillow. If you want to use, you can Pillow, or you can also use OpenCV for your things. And of course TensorFlow. TensorFlow, you have two things. One is you can directly use a TensorFlow, or you can use it with a Python Keras wrapper, right? You can use a Keras module inside the TensorFlow if you are very much comfortable with Keras. If you are using Keras, it's pretty much simple for you to build your models, right? The functions are pretty straightforward and easy to understand. Your TensorFlow model itself has Keras inbuilt in it, and it's been quite frequently updated. You don't want to worry about if I'm using Keras, how can I use TensorFlow? If you learn Keras and using it from the TensorFlow, it's pretty much enough. Like it's been keep updated every time. So, and then once you use that Keras module from TensorFlow, you can pretty much import all the modules inside the Keras library, right? So you can just leverage that. So before moving forward, I just need to emphasize a little bit on why lot of you have the doubts of whether either I have to go with PyTorch, I have to go with TensorFlow, or I have to go with TensorFlow with Keras, right? So the common difference would be your TensorFlow and Keras have been built using part of C language. All your hardware level things have been handled by a C language, and it's been wrapped with Python, right? All your files you're seeing once you install TensorFlow in your laptop or your desktop is mostly common Python scripts, right? Because it's been wrapped with Python, but the underlying operations will be handled by C++ or C files. Either it's communicating with the GPU, all your CUDA functions, all those things have been handled by your underlying C functions. And TensorFlow and Keras is not built keeping Python in mind. They are built it keeping just deep learning in mind and how the mathematical operations have been worked around. But slowly it's getting evolved, and it's been largely a more Pythonized way. But when you see PyTorch, the basic structure itself is similar to Python. PyTorch works how exactly your Python works. It's similar to how it runs in an interpreter. PyTorch also works in the same way. Each and every line is executed then and there. But TensorFlow is not something like that. Like it compiles in a way that like similar to how you compile a C file. But of course, it uses a part of interpreter. Of course, even though it's using interpreter of Python, like under the interpreter, you have a C compiler, so that it compiles and executes a program. Either it needs to execute in your external hardware like accelerator like GPU, or even CPU. This flow is same. If it is accelerated using GPUs, you have an external library supported like CUDNN to accelerate and leverage the GPU infrastructure. So this is it. So typically, if you use TensorFlow, you have a Keras module inbuilt in that, and from that Keras modules, you can import what are the other important modules like layers, sequential, data store, checkpoints, all those stuff. You can import it from the Keras modules itself. So to set the context, I'm just using a common TensorFlow dataset file from TensorFlow repository itself. Tomorrow we'll see how we, the 15th we'll see how we have their own datasets. I have my own datasets prepared for you. I'll show how you have to do. You have to create your own dataset, and you have to create a script to pre-process the dataset and add it to your Python script and build a simple classification model, right? Yeah. So this is just to reset my GPU memory. So whenever you run a training model, your GPU memory will be locked. All the data will be handled by GPU. So whatever training happened at last, it will be stay idle in the GPU. So you have to just reset the GPU memory and keep it empty. So you could see I'm just using a command called NVIDIA-SMI to see what are the process running in your GPUs. In my GPU, so I'm just getting output for every second. Now you could see Python file is running here. So either it could be some file which I've been ran sometime before. So if I stop it, it'll stop the entire Python script running in my GPU. Hopefully, okay. Just give me a minute. I'll just reset it. Yes, some other process running. Okay, let's see. We'll start this. Let's see how it goes, and we'll fix that up. Okay. So once you import this predefined modules, it may differ depending on your project. It's just basic models have been imported. I'll also let you know on the next sessions like what are the common modules have been used by companies, and what is the structure of the code they use. And when you see when companies building the code, or even for research project for that matter, people normally use environment variables. They don't just pass their parameters. Either it could be a dataset path, or it could be hyperparameters. They use environment variables. They have a common file to get all those inputs and pass it on to your training script, or your test script, or your inference script. So that's how those structure have been used. When we see how we structure the deep learning computer vision projects, we'll also add those things and see how we can leverage environment variable. So for now, we have something called a Matlab, and we've been just exporting a dataset from this cloud, Google Cloud, where they store all those deep learning datasets. It's a pretty much simple dataset you have been familiar with. It's a Flower dataset. You have to just map that URL, and you have to just use utilities of Keras to get those files from the dataset and keep the dataset loaded into our local system. So for me, it's already loaded, and we have almost 3,670 images. So once you load it, you can list what the number of images, number of JPEG files we have using a common list function from data directory.globe. So because we have data directory as Keras utils get file function have been loaded. All these photos have been loaded to this. This pointer will act as a input for, gateway for this function. So when you have this pointer like a variable, you can just call whatever other functions which help this module to work. We are calling .globe, and we are seeing what are the total number of images available in the entire data set. And we just with the length of it, because as you could see, the globe will have the list of images. So as this is using a list data structure, you can just use a length to see what are the number of counts you have in your data set. So once that is done, you can just visualize your data using, as this is a list structure, you can visualize a number of data you have, whatever, you have almost 3600 image, and you can see whatever, what are the images you have using those list structure. So it's just visualizing your data, and then then comes the part of pre-processing, right? Your pre-processing very important. Here we are loading it directly from the Google Cloud, so there is not much of things happening. But if we are using our own data set and we want to build our manual pipeline, so that is something different. For that, we have functions in Tensorflow and PyTorch that we will see how you have to build that end to end in the next session. But as of now, like just to set the context and see how the flow is, this is how, like, we have to start collecting our data and pre-processing our data. So you could see, like, I assume that a lot of you have been pretty much familiar with common deep learning terminologies, if not just mentioned in the chat, so that I could see how many of you have been working in deep learning. You may be from some other departments and you want to get into deep learning and use deep learning for your own research work. I just want to understand those things so that I can tweak a little bit for my next session. Yeah, if someone is pretty much new to it, just say yes, so that I'll pretty much manage the terminologies I use and keep it clear for you. Okay. Okay. So you could see a few messages. You have been already working on this. Fine. Yeah, I can share. I'll share the code which will be working on 15th. This is some common code. I'll have my own code which I will share you on 15th. Yeah, so that is something you require, because that we do manually collect the data and pre-process it and build the data pipeline and use it for your training data. So if you understand that basic structuring your data sets, it's easy for you to incorporate those things and starting building your own models. So the structuring also differs to model to model. If it is object detection, that is totally different, because you need to label your data specifically with objects, and you have different text file or JSON file for your labels, and you have a correlated image for that particular labeled JSON or text file. So these two things and image segmentation, all these things, the basic thing is all your common deep learning workloads, right? Either it could be computer vision, natural language processing, or within computer vision, it's object detection or segmentation. Handling your data is definitely will differ. If it is computer vision project, you just have a structure of folder and you label it through your code itself, and you can manage it. But if you're using object detection, you have to use some label tool called image label, and you have to label it and organize your labels, and then you have to read your label and map it with your NumPy array, and then you have to train your model, right? So the complexity would be a little higher, like if you're going for object detection or segmentation, comparing with classification. But slowly we can catch up with those things and easily work on that. If you're new to deep learning, or you're from non-CS or non-IT department who want to get hands-on with deep learning. Okay, I could see a lot of you have been already been using this. So let's see. So I don't want to emphasize more on what are the terminologies I've been using. Okay. So normally when you have an image data set, you have different resolutions. So you cannot have multiple resolutions because your model structure may not have been built for that, because when you do a convolution operation, when you have a common resolution, common size of image, it's easy for your model to get the features of your data and train it well. So if you have multiple size of image, even some models don't support it. But of course, very few models support different size of image, but that is not ideal recommended way to do it. You have to resize your image and make all your image into common size. For that, you have a same image height and image width, and you have to make sure all your objects, if you're doing object detection or image segmentation, you have to make sure that your objects are being captured with the resolution. Of course, you can use different resolution of images, but depending on the image resolution, you need to have a proper hardware to train your models. So typically, and one more parameter you would have is batch size. So when you are training your model, you use different gradient descent, right? Stochastic gradient descent or a batch gradient descent. So based on that, you need to also choose your gradient descent, like in whether you are training your entire data set or you're training in a batch of images that you need to specify here. So commonly, people use if you're using very basic models, people use 32 or 128. But if you're using very high-end models and very high-end images, of course 2 or 4 is what the batch size would be. I'm saying, like, if you have lakhs of images and your resolution is 120 or 920 or 120 to 120, those kind of data sets, and your model is pretty heavy, like resistant 150 or something like that, like, then you have to very careful about all these parameters. So once that is done, you have to do the pre-processing. So pre-processing involves just give me a minute. Sorry. Sorry. Yeah. So pre-processing involves not just managing your images into different way, but like if you have a training data set, you want to split it, right? You want to split it into training data, test data, and validation data. Training data is something you need to train your model, and test data would be a part of subset of your training data. But validation data, yeah, of course, you can also choose a subset of it, or you can have a new set of data which doesn't present in a training set itself, and you can validate your model based on that data. So yeah, we're doing a validation split. So it's 0.2 means we are getting 20% of the data set into validation, and we are having 80% for the training. And then you're passing the image size and batch size, and so once that is done, this is a very common, very navy pre-processing. There is something called heavy pre-processing, which requires GPU for it. Let's say you have very small amount of data. Let's say you have 1,000 data or 500 images. You cannot typically train a model and expect a model to give you the better results, right? At least even 50 or 60% of the accuracy, or it detecting the model correctly, right? So to make it work, you have something called image augmentation. What image augmentation is that when you have a small amount of data, you can rotate the image, you can change the color of the image, you can shear the image, and you can do various operations in an image and increase the size of your data, right? Now, of course, if it is a classification work, it is pretty straightforward. But if it is object detection, there are few complexities, because when you label an image and then you do a pre-processing, of course your labels will change, and your label orientation will change, and that will affect your model to learn the features properly. There are pre-built augmentation techniques available in TensorFlow or PyTorch or Keras itself, but still they are very limited. If you are very listed and you have to need to have a quality of data and increase the size of data, and doing a image augmentation manually or creating a manual script is something very much important. And then moving on to the validation step, you have this split of 20% into validation, and the thing is you're loading this training set into your training DS, and you're loading this validation set into your validation DS, and you have to pre-process both this data. So that's what happening in this both function, and not emphasizing more on how this function will work and what happens inbuilt, but for that we need to have something, we need to have different session to emphasize more on this, because this function itself have a lot of things to do. But I could share you a good cheat sheet for this to understand what happens in this function, and in whichever way you can customize it so that you can handle your own data sets, manual data sets. Okay. Yeah. Yes. And then you have something, you have to define a class name to the relevant images. As we using predefined a module from Google Cloud, datasets from Google Cloud, we just importing that class. So it's pretty straightforward. But if we are using our manual datasets, that is completely different. We have to load our dataset, and we have to use some preloaded function in TensorFlow to map whatever classes we have. We have to just name the folder name as the particular class, and you have to map it with that particular image. Or either you could do other way, you can just have and folders in zeros and ones, and 0 to 100, and you can just create a simple loop function to map the particular class name to the particular images. So these are the two ways you can do that we will discuss that I'll show you how you can do end-to-end in the 15th session. And then you have to just see visualizing your data. This is to help you to how things have been changed around and see what's happening in that. Just give me a minute. I missed out on that previous one. Okay. So with you could see with plot function itself, you can pretty much visualize all the data. So now you have from images and labels, you are taking one by one, and with a range of 9, you are iterating the loop so that all this 9 images randomly have been published for you. It's not a sequence way; it's randomly picking up 9 images in the range, and you just showing up. Yeah. So this is just to visualize. So once this is done, you can see now the shape of the image has been changed. The original shape is different, but now you could see the batch size is 32, and you have a 180 into 180 image with RGB. So this is what you have is, and you have a batch size of 32. So just to visualize how our data structured have been changed here. Just to emphasize, like when you have a data sets in your local system, what happens was, if it is a normal server or a workstation, what happens was your data resides in your local SSD or HDD. What happens was your data has been read from that through CPU to the GPU, right? So this fetch operation will take time. On top of your GPU to crunch your data, crunch your images to train your model, this data transfer operations also take time. So for that, there are a bit of tweakings available in Keras, but this is very minimal. But if you're training a very large model, and of course you would have a proper SSD setup, or if you're training very big models for a research purpose, then of course you need to have something called NVLink or RDMA access in your server to do that. That is a pretty heavy concept, but just to highlight on this, you have something called auto tune to shuffle your image and read it in a way that it doesn't increase the override your CPU process, so that you have the proper flow of data, so that your CPU has been handling all the IO operations properly. Then we have to standardize the data, because all our data has been a range of 0 to 225, because we're using RGB channel. So we have to standardize between 0 to 1, so that our models have been learning that quickly and using increase the speed of the model to learn and understand the features of the images. So this is pretty common in everything. You have to normalize this normalization layer itself in common in your convolution process, right? So once that is done, you have to once that is done, you have to normalize and layer all the images in that. So you could see after doing that, your images are becoming normalized, and once that is normalized, you don't give the data 0, 0 and 1 between zeros. So once I started the process, you could see my system got slow because it's loading the image, and my system is getting hanged. Just give me a second, like it will come up. Yeah. Yes. Yeah. So as you could see, like it's been normalized, and your values have been new pixel values have been changed here. It's not now, it's not in 0 to 225, it's between 0 and 1. You could see that 0.0 and 0.997, just a sample of image we are showing, but this is how for all images the pixel have been changed. So once that is done, we have to just start our model definition. And in Keras, you all know that sequential is the common function to use build your end-to-end common convolution process. So you just have to use those sequential module, and you have to just call the layer module, and one by one you have to build this convolution structure, right? So we have 5 images, so you have a total of 5 classes. So we have to again experiment and pre-process it, and input shape and all these things we have been passing out in this layers or experimental, and then we have to build our own convo 2D, build a convo 2D layer. And once this is done, our convolution happens with our image would be reduced to 16 and 3 layer, and then with 32, and slowly our image will become common 128 nodes. I mean, with dense layer you have 128 nodes in that as a common final dense layer. So I'll explain what happens here. Like once your convert 2D operation is done, you could see the convolution operation slide through, and then your common multiple addition operations happens, right? So once that is done, you have max pooling 2D is done, and then your image orientation will change, and then max pool 2D again. It's a pretty very basic CNN. It's been created here. So once that is done, and you have something called flatten, right? When you have a normal neural network, you have a input layer, you have a hidden layer, and you have a output layer. Like convolution is you could say it's a kind of neural network, but it's not actually actual process of how your vanilla neural network behaves, right? It's operational, right? It slides through your images, reduce the size of your dimensionality of your images, and get the final features which is very much required to decide which label it is, right? So once that is done, after the 64, when you have the 64 in this last convo 2D layer, when you have a 64 and you do the max pooling, so once you do the max pooling, you flatten it, you could see you can find 128 nodes. So each nodes have some feature of it, right? So once that is done, till max pooling 2D, it's convolution layer. After that, you flatten it. Once you flatten it, it's becoming a vanilla neural network, right? So once that is done, you again, the common process of vanilla neural network will happen here. And then you define a final output layer with number of classes, right? We have 5 classes, so the final output layer would be 5 nodes. So once that is done, you have to define an optimizer you need to use and what loss function you are going to use, and you have to just create a metrics variable to measure the accuracy and to find the measurement of how your model behaves, right? So this we use model compile. I didn't compile this. Okay. Okay. So once that is done, this summary is available in Keras, but in vanilla TensorFlow and in PyTorch, this is totally different. Okay, we are out of time. Like just give me 2 minutes. I'll just quickly round up these things. And once this is done, you have a summary of. You can see the summary of the entire model itself, and you can slowly get into training the model. So now it will throw an error because I upgraded my CUDA toolkit. You could see. The CUDA toolkit is 11 now, but that model is built around 10.5. So what happens was this is also a consideration when you have a setup and when you're building your TensorFlow scripts, you have to make sure that you're building it in a right environment, or you're upgrading your software according to your hardware. You've been hardware libraries or middleware you're using in hardware in your TensorFlow library, right? So that the communication flow is seamless and you don't receive any errors. So don't hesitate to upgrade your models. Since I didn't do the upgradation of TensorFlow. Upgradation of TensorFlow to TensorFlow 5. So it's throwing the error now. And now I'm also using NVIDIA driver 450. So that is also another issue happening here. So I have to downgrade it, or either I have to upgrade to latest version of TensorFlow so that it doesn't happen. The problem doesn't happen here. Like you could see, fail to get the convolution algorithm, probably because cuDNN failed to initialize, because I'm using the older version of newest version of cuDNN, but the script which I built using a little older version. So this compatibility issues will happen. So whenever you need upgrading your hardware or a middleware, you have to upgrade your TensorFlow also, and make sure that your scripts have been working fine with that setup. I think we almost in the time. Like if you have any questions till now, you just post it in the chat. I will have another 2 minutes and we'll wind off. And next session we'll cover more of manual way of doing things, and how you could set up your own project structure and build your own codes. I know like 1.5 hours is very low. Very small session to cover a lot of things. But still, I want to set the overall concept and tone to help you to quickly skip some steps which you don't want to explore. That you can get the input from us, and you can start doing it very fast. Yeah, this file, I'll share that, but of course, this is something to explain and predefine. I'll share a file with manual way of doing it, how you have your own dataset prepared and loading it in your system and training the model. That would be very ideal for you. You can just use the script in your own code also. Yeah. So we can have 2 more minutes and we can wind up. If you have any questions, you're welcome. So yeah, I think I should have created a Google Forms and understand a bit, and then you have to create the session contents. Ma'am, if there is no question, can we wind up?
Yes, sir.
Yes, sir.
So the next section is on 15th, right? 15th, same time.
Yes, sir. Few minutes, sir.
Hello?
Sir, 1 minute, sir. 1 minute. We can wind up the session.
Okay.
Yes, sir.
No questions. So we can wrap it up. 1 minute, sir.
My voice is a little feeble. It's not clear.
Sir, I think no questions in the chat window, so we can wind it up, sir. Thank you
Okay,
so
fine.
much, sir. 1 minute, sir. Lata, ma'am. Sorry, Bhupala, ma'am.
Yes, ma'am. Yes. Thank you so much, sir. On behalf of Sri Krishna College of Engineering and Technology, it seems to be a great honor to propose the vote of thanks to all who have helped us in making this session a very resounding success. First of all, I would like to thank my hearty vote of thanks to our distinguished speaker, Mr.V.Arihenth sir, for making an excellent presentation and making this session a very meaningful and interesting. Once again, I thank all for your cordial cooperation. Thank you, sir. Thank you so much.
Thank you, ma'am. Thank you so much.
Yes, sir.
Thank you, sir. Participants, thanks for the. This is the end of the day two, so we can meet it tomorrow. Thank you. Thank you all.